LR1-2 is all about learning some more vocabulary about angles, learning how to use a protractor, and how to name angles correctly. We're going to quick touch on something that we talked about in our last lesson, which is the difference between congruent and equal. Remember, congruent, which we can use that symbol for, is only used for objects. So I can say that two line segments are congruent. I can say that two triangles are congruent. I could say that two houses are congruent. Okay. Equal is only used for numbers. So if I measure two line segments, their measurements are equal. If I measure two angles, their angles could be equal. If I measure the height of two houses, their heights could be equal. But I have to have numbers involved to use equal. Okay? We've used equal more in algebra because we're working with numbers. Now that we're working with objects, we're going to be using congruent more. When I ask you in this class to draw, I am asking you to be exact. So that means you're going to pull out rulers, protractors, compasses, all of that. We'll do a lot of drawing in LR2. In LR1, so in this unit, we're going to mostly sketch. We don't really care what it looks like. We're just trying to get it done and be vaguely correct. In example 1, we're asked to sketch a quadrilateral named CLEM. We want CL to equal LE. Angle LCM is congruent to angle LEM. And line segment CM is congruent to line segment EM. So I'm going to start with a quadrilateral. Hopefully you know that a quadrilateral has 4 sides. We want CL equal to LE. So when I write my names going around, I have CL, EM, CL, and LE have equal measures. You could say that their line segments are congruent. The way I mark that in my picture is with little tick marks. We're going to ignore our angles for a second. When I get to this step, I'm told CM is congruent to EM. Well, I already used 1 tick mark, so if I go in and do just 1 more tick mark, people are going to come along and look at this, and they're going to think that I think that all the sides are equal, when they're not. So I'm going to use a second tick mark to say, no, only CM and ME are equal, CL and LE are equal. Great. My angles then, I'm looking for LCM. When I'm naming angles, I'm going to start at the first letter, go to the second one, stop, turn, go to the other one. This is my angle. My other angle, LEM, is over here. The way that I mark angles congruent is I'm going to draw in the little angles, the little half circles, and then do a tick mark. Now when you look at this, there is no way that this distance is actually the same as this. If I got out a ruler, I would have failed miserably. But I wasn't asked to draw, I was asked to sketch. So it is okay if your sketch is not to scale. If it really bothers you, you can make a little note in the corner that says not to scale. All right, so an angle is going to be made of any 2 rays that share an endpoint, and we're going to call that endpoint the vertex. When we talk about angles, we're going to say angle and then 3 letters, or in some cases we can say just 1 letter, and we'll talk about what that case is in just a second. When I write it, I'm writing a little baby angle and then ABC. Or again, if I'm able to use just 1 letter, I can use just angle B. My special case, so I have to use 3 letters if there are multiple angles. So if I have angle A here, B is my vertex, C is on my other leg, and then let's say I have D here. If I say angle B, I don't know if you're talking about this angle, or this angle, or this angle. So in that case, I have to use 3 letters. But if I have an angle that looks like this, if I say angle B, I could only possibly be talking about that angle. So in that case, I can still use 3 letters. It's never wrong to use 3 letters. And if you're stressed about this, just always use 3 letters and you'll be fine. But you could also use angle B here. So we're asked to name this in 3 ways. One way would be angle ABC. Another way is angle CBA, right? I could go either direction as long as B, my vertex, is in the middle. Or because there is only one angle pictured, there's no other angle B that I could possibly be referring to, I can use angle B. When I talk about the sides of an angle, I mean the lines, okay? The actual rays that are coming out of that vertex. The vertex, meanwhile, is that shared endpoint. My angle bisector is going to share the same vertex as the angle, and it's going to split the angle exactly in half, or I could say into 2 congruent angles. So it's still going through that endpoint that those 2 legs share, and it's also going to be a ray, and it's going to cut it exactly in half. And this isn't the best drawing, but that's okay. Right angles are going to measure exactly 90 degrees, and we're going to mark them with a little square in the corner. So if I have a right angle, even if I didn't draw it very well, the way that I prove that it's a right angle in my drawing is I draw the little square. And all of a sudden, even if it was really poorly drawn and it actually measures 88 degrees, that's a right angle. That shows that, hey, no, we know it's a right angle, even if it doesn't look like it. Acute angle, think cute things are little. So here's a bunch of little baby animals. They're going to measure less than 90 degrees. Obtuse angles have to be more than 90 degrees. On this page, if you click on the T on your notes, you are able to drag and drop the different angles through Notability. The important thing is that all of your acute angles need to measure less than 90 degrees. Your right angles should equal exactly 90 degrees, and your obtuse angles are more than 90 degrees.